Well, hello, welcome everybody. This is soyokazeha from SMGens with yet another video. Well, this time, this video is about Numpy for ML beginners. This tutorial will be for those who know a little bit about Python language and they are going to learn about machine learning. So, if you are trying to learn machine learning, before that there are many steps, like you should know about libraries like Numpy, Pandas, skitlearn, and you should know about data preprocessing. So the first step will be Numpy, so we'll be checking out about Numpy. So let's get started. Well, what exactly Numpy is? Well, Numpy is a library used for scientific computing, and also it has array objects and derived array objects that are masked arrays and matrices. Well, furthermore, it has some fast operationals that can be operated on arrays that are mathematical, logical, shape manipulation, sorting, selecting, some Fourier series, transformations, and much more. Countless more. So at core, it has an n-dimensional array object, which can be referred as ND array. Since it is an array, it is homogeneous in data, and also there are some pre-compiled programs in it, functions in it that are used for performance. So why Numpy and what's the difference? Well, Numpy has a fixed size in comparison to Python sequences that are less and lists that doesn't have it. So lists are not fixed, that can be grown or shrinked as per need. So its length can be decreased or increased throughout the program. And Numpy array elements are homogeneous, as I said before. Well, in lists it can be homogeneous, it can be heterogeneous. So, and also Numpy array facilitates advanced mathematical on large numbers of data. So as I said, it stores large numbers of data and it has some advanced mathematical formulas that can be operated on those data. So also, since it has pre-compiled functions, it is fast, much fast. So that was done. Let's head over to practical. So here we have opened our Jupyter notebook. We will be doing the practical on Jupyter notebook. So let's create a new notebook. So here we can create a new notebook. So we will be doing in Python 3. So first let's import Numpy. So Numpy, if you don't have Numpy, you can use pip install Numpy. That's that. So for that you should have a pip package manager, that is Python's package manager. Pip, from that you can install the Numpy library, that is Python library. So that was that. So let's import our Numpy library. So import Numpy as n or np. You can import it as anything, it is on your choice. You can even import it as God, so that is on you. So for convenience we will import it as n, and for Numpy, why not? So it's imported. So it's imported. Now since Numpy has array objects, so what is an array? We have discussed that. So how we create an object is by making a variable like arr, that is array, that will be equal to n dot array, and that is predefined. That is an array object we are creating now using array class, array function here, and here we pass a list. It can be anything, so it can be 2D, 1D, 3D, ND. So it can be n-dimensional array. So for now we'll be making a 2-dimensional list. So let's make it 1, 3 4 and 2 4 6. So that's how we create. So if we print it out, so that's how an numpy array looks like. So it takes a argument that is list, and that's how we create a numpy array. That's easy. Now for casting, it does casting on two bases, like automatically. If I make one of it as a floating number, it will make all the numbers as a floating point. So this is what we call it as upcasting. So it will take the largest type, that is the floating, that is bigger than the integer, that is int, and it will cast all the numbers in that array to floating. So if we want to cast an array manually, we will use a argument that is d type equals to, and now you can either make it as integer, that is int. Now here the choice is 32 or 64. We'll make it 64. So we know, since this is not an integer, it will be converted to 0, because that it is 0.6. So let's check that out. So yes, it is converted to 0, and here you can see its type is int 64. So if we make it float 64, so everything will be upcasted to typecasted to floating point. So now since when we were using, that is what we can say, list, so let's make a list like L equals to a list, that is 2 3 4. Okay, now what we are going to do is make another variable. Let's say v is equals to L. Okay, now what we have done is we have created a list and created another variable that is equated to that list. Now if we change anything in the list, in this v, let's say we append, now it's another function that is defined for the list, not for the arrays. So it is defined for the list. So if we want to add any element to list, we use append command. So append, so we want to append like 3, let's say 6 in it. Okay, now what we'll see, like if we print v, since we have appended 6 in v, it should be added to v. But if we print L, since we haven't done anything to L, it should print 2, 3 and 4, but it is printing 2, 3, 4 and 6. So what happened here is that whatever we are doing to v is also reflecting to L, since it is equated to this L. So since it doesn't mean it is copied to v, it means they both share the same address in the memory allocation. So whatever changes we do to v is also reflected to L. So to overcome this, in Numpy we copy by using a function name copy. So let's say we make another variable that is crr is equals to arr is equals to, let's see how we do it, it's arr dot copy. So that's how we copy it. Now if I make another variable that is brr is equals to arr, now if I do brr 0 and the first element of the first column, that will equate to 2. Now what we have done is we have changed this 1 to 2. Now if we print arr, here you can see it is changed to 2. But if we change anything to CRR. Now say, let's see, now CRR 0, sorry, 0 and CRR 1. It's the second element, that is 3 here. We'll change it to 1, equal to 1. Now here you will see, let's again check ARR. You will see now it is not changed. Now you will see that the 2 is changed because we have compiled this after this, so it is changed already. But you can see that the second element of the first list, since it is 2-dimensional, is not changed here because we have copied. Now whatever reflected to this variable will not reflect it to array. Now if we print CRR, you can see since it retained the very first copy, that is the very first image of the ARR, which is copied into CRR, therefore it has the first element to be 1, and since we changed the second element to be 1, so it is changed. Now if we have to typecast, since we have code everything here, now you don't want to go up to the code and change it there, so you can also externally typecast it. Since this is internal typecasting, we can do the external typecasting. Now for that we have again a new command, I say. So for that, now since it returns it, so when we apply this command on array like arr dot, that the function that I was talking about is as type, so it is used for external typecasting, and it takes an argument that will be which type, so we will be converting them to int 64. So now here it returns an array, so it will print the array whatever we are doing here, but it doesn't change the ARR array, but instead it returns it. So we have to store it in a variable. So let's see, we make a variable vrr and equate it to arr.asType. Now let's see, the np is not okay, so it's not np, it's n we have defined. Okay, yep, so that was my mistake. Okay, now if we print vrr, you can see the type casted to integer 64. So at first it was float, now here it is 64 in integer type, so its type is changed to integer from floating point. Now also there is one more thing in array, the last thing we'll be doing in this tutorial, and that is nan. Now what does nan means? It is much like none. So if you don't want to enter any kind of data on a particular point, let's say arr on the third element, let's say the first column, the third element of the first row will be 2. So if you want to change 4 to something, we don't want it, we don't want any value to be there, so we will replace it with n.nan. So nan is like none or null, so it has no value there, it has no value of it. So if we print here arr, so we'll see it is written nan. Nan is not a string, again I say, it denotes null or none, that is it has no value here at this point. So that is all the basics of the Numpy, how you can create a Numpy array. We have seen here how you create a Numpy object, then we have seen why we don't do this for copying an array. We use a copy function to copy it, and also how if we change something to a list, when it is equated like this, it will reflect to the original list. And also we have seen the external typecasting, how we do it, and at the end we have seen what NN is. Now whatever this I'm writing in this notebook, I'll be pushing it to the GitHub, so the link will be in the description of the GitHub I'll be posting here, so it will be much more understanding. I will cut short something and add some comments so you will understand it better. So thanks for watching. Subscribe if you haven't subscribed it yet a channel, and also I'll be doing more of these Numpy videos. Like next will be about Numpy basics, so how you will be doing some operations on Numpy and how you can use it in the real life, like for machine learning and stuff. So that was that. Thanks for watching again. Bye for now. Take care.